suppose this is a turbine. So if I show you through a pointer, so if this is a turbine, I told you what is control volume. Control volume is basically a fixed region in the space which is focused and in which some mass can enter and the mass can leave the system. So basically it is not a fixed mass system. It is a fixed region system where this turbine or this boundary will remain the same for the throughout the whole process. But what is happening? Some mass is entering into the system, and after that some process is happening inside there and the mass is leaving the system. So this is happening inside this device. This is basically called control volume, and the boundary of this control volume is basically called the control surface. So it is something like just like a boundary. Okay, so what is happening inside this turbine? In the turbine, what is happening? Some mass is entering, maybe m dot, with a high velocity and high pressure. Whenever this mass entering into the system, there are several blades inside the turbine. So it is impacting on those blades, and due to that impact, it is causing the rotation of the shaft. So basically what is happening? Your control volume is performing some kind of work. That work you are extracting from the system. It is basically the work done by the system. What you are doing with this work? So basically rotational energy is basically a form of work. What you can do, you can feed this rotation inside a generator by simply putting a coil which will cause the flux cut, and due to this flux cut the electricity will generate. So what is happening here, that some mass is entering, it is having some energy and it is undergoing a process, a physical process, and finally after the process it is leaving the system. During this whole thing, what is happening, that the system is losing, that the incoming mass is losing energy, and that energy is finally converted into useful work which can be used for any purposes. Maybe driving a engine, or maybe driving a generator, whatever it can be. So this is basically an example of a control volume system. So control volume system is basically different from the control mass or the closed system. In the closed system there is no mass transfer, but here what is happening, there can be a heat transfer. So during this process, even you can supply some amount of heat, even you can extract some amount of work. Whatever you like to do, you can do. And also the mass can enter into the system and the mass can leave the system. So this kind of systems are basically called the control volume system, and this process is basically called a flow process, because the process is happening during the flow. So now, so just think about a flow process. Just consider this is your bathtub. So what is happening? Some water is coming into the system. So due to that, the water level of the bathtub will start to increase. So maybe hopefully you have seen in the movie scenes mostly. So what will happen? The water level will start to increase, and there is one small outlet. It may be somewhere there. So the water level will slowly increase. If you close the outlet, whatever water is coming, it will increase the bathtub. Now if we slowly open the valve there or the outlet, it will start to lose the mass. So water level will start to fall. So it will depend upon that. What will be your water level? Depend upon that how much mass is entering into the system and how much mass is leaving into the system. So that will create that per unit time how the water level will increase. Just like your small in your class 6-7 arithmetic problems, maybe the typical Casey-Nag problems. So what is happening, that there is some m dot in, or total mass entering inside the control volume. Next, the total mass that is leaving the control volume, which is equal to the net change of mass during inside the control volume during the delta t. So you can write down that my m dot in, the mass which is coming inside, the mass which is leaving the system is basically the rate of change of mass of the control volume. So basically what I'm trying to say that whatever mass is coming into the system, it may not be the same mass is going to leave the system. There might be accumulation, but if there is no accumulation, in that case we can say whatever is coming, that same thing is basically leaving the system. So there is no accumulation, but there are possibilities where the accumulation can happen. Is that right? So that is basically the conservation of mass principle. So what is happening? The total mass of the control volume can be written as m dot mcv, so which is basically the density into the volume if we integrate over the whole control volume, and that what is the cause, the rate of change is basically that mcv dt, so which is basically just simply a derivative of this term which you have already written there. Okay, so basically what you can write, that the same thing I am trying to write down, that is basically the general conservation of mass. What is basically this? So summation of mass in minus summation of mass out equal to the rate of change of the mass of the control volume. Just like whenever you try to see this example or try to see this formula, you just try to imagine the bathtub situation. Okay, so now just I am giving one example. Suppose this is a control volume where you can see that there is one inlet through which water is coming through m dot equal to 2 kg per second. There is another inlet through which water is coming through 3 kg per second. And finally, if there is no accumulation, I can say the mass of leaving stream is basically 2 plus 3 equal to 5 kg per second. So it may be the 2 inlet 1 outlet system. There can be several input, several output system, but whatever happening, if it is a steady flow process, just I am removing this term from the system. If I consider that this term goes to 0, this is basically called a steady system. You know what is the meaning of steady? Steady means anything which is not changing with respect to time. Is that right? So this is basically called a steady system. So steady, so if it is steady, there should not be any kind of accumulation. So whatever is coming into the system, the same thing is leaving. So we know that the m dot is the mass flow rate. So mass can be written as what? The volume flow rate into the density. The volume flow rate is the velocity into area, just like what you have studied in your fluid mechanics in your class 12, that it is basically the rho 1 a1 v1 equal to rho 2 a2 v2. It is happening for a single stream. If there is only a single stream, I can write down that the mass of inlet equal to mass of outlet. But there is one assumption. What is that assumption? What I am saying, that this rho 1 and rho 2, these are different. This rho 1 and rho 2, this may be different or may be same. If they are same, I can simply replace that density, and for incompressible flow where the density is not changing, I can simply remove the rho. I can say on that v1a1 equal to v2a2. This is valid for a steady incompressible flow. If the flow is compressible, that means if the density is changing, it may happen rho 1 v1a1 equal to rho 2 v2a2. But if it is a incompressible flow, then the density will remain constant. So basically what you can say, for steady flow of liquid, the volume flow rates as well as the mass flow rates remains constant, since the liquids are essentially incompressible substances. So the volume flow rate, we can say that these are constant. So suppose if I consider it is a compressor, so some mass is entering, some volume is leaving, and here the mass is same, but the volume is different. So because compressor handles compressible fluids. Okay, so conservation of mass is always true, but the conservation of volume flow rate is not always true. Depends upon that if it is a incompressible or compressible. So hopefully you understood what I'm trying to say. Now, this is basically the mass conservation. So first thing I told you that for a simple compressible, what you have discussed here, that for a control volume, if it is my control volume system, so if it is a control volume, what is happening? Some mass is entering, some mass is leaving. During that point, there is some work done, some kind of shaft work, there is some kind of heat transfer, some mass is coming, some mass is leaving. So what I can say, there is two things. First thing is that there should be a mass conservation. And the next thing is basically the energy conservation. So we already have discussed about the mass conservation thing. So if there is no accumulation, whatever comes, the same thing is leaving. If there is accumulation, there will be some dmdt. That dmdt will represent the accumulation part. Okay. For steady thing, whenever I say it is steady, that means the function of time is not there. That means there is no kind of accumulation. We can say that the whatever comes, the same thing is leaving. Okay. So any doubt up to this much? Any doubt?
Sir, I have a doubt. You said that for a control volume process, the system allows both mass and heat to transfer across its boundary. So can we say that it is an open system?
Yeah, perfect. Control volume and open system, they are similar words.
And can we conclude that all open systems are control volume systems?
Always.
Okay.
We can say that. They are similar words. Synonyms.
Okay, sir.
So, I discussed about the conservation of mass principle. Now, I will try to think about the energy principle. Let's try to think what is happening in the form of energy. So, let's see that you see that the m dot I is entering. So, it is the m dot I which is entering into the system, and it is the m dot E which is leaving the system. So now we already know that if the system is steady, that my m dot I will be always equal to m dot E. And if the system is not steady, that means the water level is changing, or maybe something is happening inside, that means that is causing an accumulation or decrement of the level. So that's why there might be some transient term. But here now there is no transient term. We can consider that this m dot I equal to m dot E. So now this is, I am talking about in terms of mass. What is happening in terms of energy? You are adding some amount of heat into the system, which is basically the Q dot. And I have considered that this Q dot is heat addition. Why I have considered it as a heat addition? Because I want to make it positive. So I'm not going into this complexity of the sign. I am considering that there is a positive heat transfer to the system, and the system is performing some work. What do you mean by system is performing some work? Because just consider, if it is a turbine, so there will be rotation of the blades. If there is a rotation of the blades, it will cause some kind of rotation, and that can be considered as a work output. So the system is performing some work. So it is basically the work done by the system. So there is heat transfer to the system, and there is some work done by the system. But you have to understand, whenever I am talking about a flowing system, these are not only the form of energy. This heat and work are the two form of energy that exist at the boundary, but there is also some other form of energy, and that form of energy is basically transporting with the mass. The mass is taking some fluid which is having some energy, and the mass which is leaving out of the system, that is also having some energy. So what is this energy? First, I know that it will have an internal energy, U. It will have some V1 square by 2, some kinetic energy, and there is some potential energy. So these are the form of energy. So if I try to look for a account balance means how much money I am getting from different sources and how much I am paying for Netflix, Swiggy, and other things, rest of the things. So if I try to go for a account balance for my student account, what I will say that the energy cannot be created and energy cannot be destroyed. So whatever energy comes, the same energy will leave if there is no accumulation. If there is accumulation, there will be a rate of change of energy of the system, just like what happened for the mass. If the system is steady, the dmdt term goes to 0. If the system is not steady, the dmdt term is not equal to 0. Similarly, here also the same thing is going to happen. If the system is steady, the dEdt term will be 0. If the system is not steady, the dEdt term is not equal to 0. So if I write down the energy balance equation, what I can write, net energy transfer rate into the system. So it is the heat that you have supplied to the system. It is the input energy, the mass of the incoming stream, which is having some energy. This is E1. What is E1? E1 is nothing but this already I have written here, that this internal energy, kinetic energy, and the potential energy. So net energy transfer out of the system. So whenever the system is performing work, it is losing some amount of energy. So this is the system out of the system energy, and this is the energy which is going out of the system with the moving stream that leaves out the system. So if I go for energy balance, simply subtraction of this. So that is basically the rate of change of energy of the system. This is the money that you are getting from your parents every month, and this is the money that you are getting from your tuitions, private tuitions, or maybe online teaching, or maybe some other relatives. This is the money that you are paying for your rent or maybe your travel expenditure, and this is the money that you are paying for your recreation purpose, for watching movie, subscribing Netflix, Hotstar, or maybe ordering food, whatever it is. So that is basically giving a net balance increment of your account. Most of the cases it goes for negative in your student life. So you need some additional generation. Otherwise the balance level will continuously fall throughout the four year. So here is also something like this. So if I write down the energy balance equation, it will look like this. It is the incoming energy. It is the incoming energy, incoming money to your account. It is the money that you are expending through different sources, and it is the situation of your balance. It is basically the growth of your balance. Expending more, this term will go to negative. If your earning is more, this term will become positive. Okay. So I am considering the transient part of the equation. Now let's see. So let's try to expand the term, which is basically the specific energy, that internal energy. Specific energy is basically the internal energy, the kinetic energy, and the potential energy. The K is basically the kinetic energy, P is basically the potential energy. So finally I can write down that it is basically this. So I can write down it is basically my final potential energy is basically, I can write down that this, and this is basically, finally it will cancel, but this is basically the reference term. That's why it is written something like C. At this point of time you can simply ignore it. So just consider that this is my G. So finally it is V square by 2G. It is Z. Okay, so it is the internal energy. Fine. So now let's try to understand what do you mean by work done by the system. This work done by the system is little bit crucial. You have to understand it very well. So what is happening, that what is the work done by the system? All the power all of the power transferred into the system or out of the system. So we already know that there is some kind of work done by the system due to the rotation of this turbine or something like a system work. So what I can write that this system work can have two components. One is the W dot, one other is a W dot fluid. This fluid is called basically the flow work. What is flow work? I will tell you later. So this part is basically the regular work output. What I am getting at the turbine, what I am getting at the compressor work, all this work are basically the mechanical work output. But there is also another component that is basically called the fluid work. Now I will explain what is called fluid work. This part is little bit tricky, please pay attention. So now what is happening that the fluid work is the power which is required to move the fluid in and out of the system. What do you mean by that? Whenever the mass is entering the system, what is happening? Whenever the mass is entering into the system, that time the mass is doing some work to enter inside the system. Because the system is not allowing to the mass, so it has to push it to enter inside the system. Whenever the mass is leaving the system is throwing out the mass. So system is doing the work. So basically if I give you one illustration, so this W dot is already known to us. It is basically the work which is happening at the system boundary. It can be boundary displacement, rotating shaft, it can be electrical work, whatever it is. But we are now concerned with W dot fluid. What is W dot fluid? I told you. Suppose if you consider that some mass is entering into the system. So this is part. If you look at this part. So whenever some part is entering into the system, the inside mass is basically pushing the incoming mass so that it should not enter into the system. So what is happening? It is the mass which is entering into the system, it is basically pushing this piston to enter inside the domain. So this work is basically kind of work done on the system. That's why it is negative. And what is happening there, if we consider this, if there is a piece of mass and this mass is leaving the system, that means that time the mass which is there, it is basically pushing this mass and it is forcing this mass to leave the system. That is basically is kind of a expansion. So this part is basically the expansion and this part is basically the compression. Compression means work done on the system and expansion means work done by the system. So due to that, if I try to find out the expression, what is that expression? The expression is, we know the force is what? The instantaneous pressure here into the area. So it will be PV. And if I write it like this, so the compression work is this. And this is the expansion work. So if I take it, account it and expand the force, it will become pressure into area into the velocity. Similarly here also the same thing, pressure into the area, this. So now this air into velocity, area into velocity will become the volume flow rate, which is equal to Q or V dot, and this will become V dot I. So this is compression, that's why it is negative, and this is positive, that's why it will become positive. So this is the other part of the work. So I know that I can express this volume as mass flow rate into the specific volume. I know that the volume flow rate is basically an extensive property. So I can represent this extensive property in terms of some intensive property into the mass. Similarly, here also I can do the same thing, that volume flow rate can be expressed as mass flow rate into the intensive property. So this is my final flow work. Here already I have considered the signals, the sign. So this is expansion work is positive and this is the compression work. So what kind of compression? Whenever the mass entering into the system, it has to push the system. So it is experiencing some kind of compression. That's why it's this sign is negative. Whenever the mass is leaving the system is throwing out the mass. So basically, if compression is happening here, if the compression is happening here, the expansion is happening there. So it is the positive work. So that's why this W dot fluid should be taken care along with this W. We know the W work plus this W dot fluid, that is the net fluid work. So if I take it inside the final expression.
Hello, sir.
Just wait for 1 minute. So this W system can be written as W dot plus W fluid. So if I expand the W fluid will become this. And if I now include the P dot VE inside this M dot, if I take M dot I common from there and M dot E common from there, finally this PV will go inside the bracket. And finally, this U plus PV, we know that it is basically the enthalpy. So I can express this as a enthalpy. So this is my enthalpy. And this is the final form of energy balance equation. Now please start to ask your questions.
স্যার বলছি আগের স্লাইডে লাস্ট 3টে লাইন একটু বোঝাবেন আরেকবার?
So I told you that this W can be written as the this fluid work is happening because whenever some mass is entering into the system, it has to face a resistance. It has to compress the gas to enter inside the system. So basically you can consider some kind of a virtual piston. So if this is the new mass, if this new mass is coming into the system, it has to resist this pressure, then only it can enter to the system. So this is basically compressing the whole control volume. So we can consider this is the inlet work. And whenever the same thing is happening at the exit end, the same thing is happening at the exit end. So the inside pressure is basically pushing the gas. So basically it's kind of something like an expansion work. Now this work, whenever it is entering into the system, it is a compression. That's why this would be negative. That's why I have taken the negative sign. And whenever you are pushing the gas, so it is basically a displacement, positive displacement work. So it is positive. So at the inlet, it is a compression. At the exit, it is basically expansion. So now pressure into area, that is basically the force. And what is this? This is the velocity. So why there is a velocity? Because F into dx, but as you have written as dot, time derivative. So the displacement time derivative is basically the velocity. So force into velocity, because you are talking about power. Your work is what? What is the unit of work? Force into displacement. What is the unit of power? Force into velocity. So that's why the velocity comes there. It is happening per unit time. So P into A into velocity. This is not volume. This is velocity. Now area into velocity, that will become the volume flow rate. So this V dash, that became the volume flow rate. Now this volume flow rate can be written as the mass flow rate into the specific volume. I know that what is volume. volume is equal to, total volume is equal to mass into specific volume. So if we take both side derivative, it will become m dot into small specific volume. Now if I take out the mass flow rate and insert this PV inside, so it will be something like this. So this is the final expression of flow work. So it is the additional work which is happening due to the flow process. So if I take out this part and inside the main equation, so it will look like this. So this PV will go there. So if you see there, this is PV, there is a negative, and m dot E, there is a negative. So this PV will become a positive whenever it is going inside the bracket. So it is going inside the bracket, it became PVE. And here also this is negative, so it is basically the positive. So this positive will go inside the bracket, it will become positive. So finally this U plus PV is defined as enthalpy. So enthalpy is what you have. Now you can understand the definition of enthalpy, what you have read in your class 12, that enthalpy is basically the internal energy plus the flow energy. So this is basically the flow energy, what you have studied in your class 12. Now you understood that how you got the flow energy. So this is basically the enthalpy. So if we replace this U plus PV from this equation, this contain the flow work plus the internal energy. That is basically called the enthalpy. That is the definition of enthalpy. What is H equal to U plus PV? Why it is called H? It is defined like this. It is a definition. Okay. So finally you are getting this expression. This is the transient state energy equation.
Sir, what is the GC here?
Any doubt?
Yes, sir. Sir, what is the G suffix C?
Yeah, I told you that. Yeah, I told you that you can simply ignore the GC. I can simply told you that you can ignore the GC, but actually what is GC? GC is the gravitational based on where you are performing the experiment. And what is G? G is the present situation. So basically you can consider that one is the standard. Suppose you perform this experiment in moon. So in that case the G will change. So the reference energy will change. That's why you simply forget this GC. For
okay, sir.
If you are performing it in Earth, your G equal to GC. I should not put this GC. It is confusing you at the early stage. So it is my mistake. Ignore at this point of time that G equal to GC. Okay. But actually, if you try to understand the insight is that if you performing the same experiment in moon, or maybe if you are performing the experiment in maybe Mars, the same equation can be used based on a same reference. So it is basically the reference gravity. Just simply forget at this point of time. You can consider that G by GC equal to 1. It will be easier for you. I am from the next slide. I have removed this part. So I have written it like this. Do you understand this? This equation is do you understand this equation? What is the meaning of this equation? Yeah, what is the meaning of this equation?
D dt here is equal to 0. So EI is equal to EF in this case. And so Q minus W is equal to that energy difference.
Very good. So there is some incoming energy. There is some, this is the system, the energy that is leaving from the system. This is the energy that is entering into the system. This equal to Q minus W. So just like the side change. So you got it. So this is the, if you go back again, go back where we started from there. So it is the energy into the system, it is energy out of the system. So if we subtract it, I will get this expression. This expression will lead me this equation. Now if I expand the EI, it will give me it will give me this expression, and finally if I include the fluid work, it will be something like this. Finally I can write it like this. So final, if I replace this right term, this term equal to 0, and for a steady system I will get this expression. So this is not for the steady system. If I make it steady, it will become like this. Any doubt up to this much? Any doubt up to this much? Shall I repeat the whole part again from the starting point? Complete silence. So please respond to my question that do you understand?
No, sir, it's okay. Yes, sir.
It is almost okay
Yes, sir.
or completely
sir.
okay? Completely okay.
Yes, sir, it's okay.
Do you have seen this kind of similar equation anywhere?
Bernoulli's
Bernoulli's equation. Bernoulli's equation. Is it look similar to this?
Yes, sir.
Yes, sir, that energy part.
Energy part is not there. So what I'm trying to say, the Bernoulli equation is also kind of a energy conservation equation of a flowing system. Similarly, this equation is also the same equation for a flowing system. Only thing is that here you are considering the heat and work transfer, but there you do not consider the heat and work transfer. So how Bernoulli's equation can be deduced from this equation, I will show you in some other classes. But I am trying to say this is the generic form of Bernoulli equation. If we apply some set of assumption, then only we will reduce it to the Bernoulli equation. So if we try to see the assumption of Bernoulli equation, after the class you just open the textbook and see the assumption of Bernoulli equation. If I apply those assumption on this equation, I will get the Bernoulli equation. But tell me, what is the assumption of this equation? What is the assumption of this equation?
So steady state.
Steady
It is
state.
steady state only.
So it is basically steady state equation, because in this equation I do not have the dEdt part.
Yes, sir.
So the energy of the control volume is not going to change, or there is no kind of mass or energy accumulation happening inside my domain. So this is basically called S. This is basically called S F E E. Please remember the name. It is basically called the SFE. What is SFE? SFE.
Steady flow energy equation.
Excellent. So it is basically called the steady flow energy equation. It is valid for only steady flow. So now the question is that, sir, why you are calling it steady? You have rate. Something rate is there, but the rate means there is a rate. So what is happening, that is basically a process, but nothing is changing with respect to time. So if you look at the control volume constantly from the staying from the outside, you will say nothing is happening. The control volume temperature will remain same. the control volume size will remain same. Nothing will change inside the with respect to time. This is the energy steady flow energy equation. There are several devices where you can apply the steady flow energy equation to analyze the device. Whenever you are trying to go for an energy balance, you have to apply steady flow energy equation. Suppose now you can consider that all of you became a energy auditor. What do you mean by energy auditor? Energy auditor is basically a person who calculates that how much energy is coming and how much energy is going to leave. If you became a energy auditor, what you can do, you can select any device and check how much energy is coming and how much energy is leaving. So whenever you are analyzing these devices, everywhere you can apply the steady flow energy equation and check how much energy is coming and how much energy is leaving. Now before that, we have to understand that what do we mean by these devices. Now you are entering inside the engineering thermodynamics. So basically this is basically the engineering part. Now previously you understood the conceptual part. Now you are going to analyze the devices. So just I am giving one example. There is one device that is basically called a nozzle. Have you heard the term nozzle or maybe the diffuser? What is nozzle? Nozzle is basically a control volume where some fluid is entering with a low velocity. You are continuously reducing the cross-sectional area, so what you can get a high velocity. So it is basically kind of a device that increases the velocity. There is another device that is basically called a diffuser, where the incoming velocity is high. As it is flowing inside the devices, you are gradually increasing the cross-sectional area. As you are increasing the cross-sectional area, what is going to happen? The velocity will reduce. Why the velocity is reducing? Because to satisfy the continuity equation that already you have studied, that m dot equal to m dot, whatever is coming, the same thing should leave the system. So the velocity will reduce. This is basically called nozzle and this is basically called the diffuser. So if I apply the energy balance equation, my heat transfer to the system, heat transfer to the nozzle or diffuser is zero, because I am not heating it. There is no kind of expansion work, and if they are at same potential height or the potential energy level, only I can write down the energy in equal to the energy out. So m dot h1 plus v1 square by 2 equal to m dot h2 plus v2 square by 2. Do you understand how this equation I got? Have you understood this part? If I go back to the previous equation,
Yes, sir.
this will become 0. This goes to 0. There is no heat transfer. There is no work transfer. There is no change of potential energy. So this became this. Okay. So this is the function of nozzle or diffuser. So just like this. This is basically the nozzle. So this is the nozzle. So what it does, as you are moving along the length of the nozzle, your velocity increases. And what nozzle. So just you can consider nozzle where you have seen nozzle, maybe at your somewhere in your shower. So it is entering at low velocity, but finally it is impinging like a jet. Okay. So similarly, there are several devices. So it is called turbine, compressor, fan. These are basically the several devices that we use in our mechanical engineering applications. Just like whatever you are going to, whatever electricity that you are getting from in a power plant, it is finally generated inside a turbine. So what is turbine? Turbine is basically a device. Whenever some fluid is crossing the turbine, it is hitting the blades of the turbine, and which is basically causing a rotation, and the rotation is basically finally coming out through a shaft, and that shaft is driving the generator, which is causing the electricity generation. So this is basically the purpose of turbine. How turbine looks? The turbine will look like this. This is the typical gas turbine which is used in our aircrafts. The diagram is visible.
Yes, sir.
Yes, sir.
So this is the size of this turbine. Whenever some jet is hitting this turbine, it is causing a rotation, and this rotation is finally transferred into this shaft. So see the scale of this device. So it is causing a rotation, and finally you are getting some kind of power output. So basically what is happening inside the turbine, so you are heating with a high velocity, it is converting into rotation, and due to this process the pressure drops because you are extracting energy. As you are extracting energy, the pressure will drop. So it is the basic definition of turbine. What is compression? So whenever you want to increase the pressure of some fluid, so you have to supply energy from the external. So this external energy is going to add to the fluid energy, and finally the output energy will increase. Just like I told you that two things you can do. Some fluid is coming with some energy, you can extract the energy, and finally the fluid will leave the system with some low amount of in which the fluid is coming. You are adding some energy to this fluid. What kind of energy you can add? You can add pressure, you can add velocity. Due to that, the leaving fluid has higher energy. That is basically called the compressor. Okay, so the two important devices
Hello,
in
sir.
any power plant.
স্যার প্রিভিয়াস কি বললেন আরেকবার একটু রিপিট করবেন, কানেকশনটা লস।
Okay, so basically there is two kinds of device. One is called power producing device, one is called power absorbing device. The device which extract energy from the incoming fluid, that is basically called a power producing device. Just like turbine, your incoming fluid will have a higher energy. You are extracting that energy from the fluid and converting the fluid into a low energy fluid. That is basically the turbine does. It absorbs the kinetic energy of the incoming fluid, causes a rotation, and finally the fluid leaves the system with low amount of energy. Compressor, what is compressor? Compressor is power absorbing device. It absorbs electricity outside the device, the incoming fluid, so that the fluid which leaves the system has higher energy than the incoming fluid. It is basically called a compressor. Now you understood the difference between these two devices.
Yes, sir.
So the shaft is driven by the turbine, but the statement is clear. Whenever there is a turbine, the turbine itself driving the shaft. But if you have a compressor, the compressor, you have to drive the shaft to rotate the blades so that the energy of the blade get transferred to the fluid. Do you understand this?
Yes, sir.
No, sir.
No. So let's see, I will show you. So this is basically a compressor. These two things are look similar. Is that right? Is that right? So the turbine compressor, they look similar. Here for turbine, what happens? The incoming fluid has the energy. It is driving this whole device, which is causing a rotation at the output. But for compressor, you are driving this shaft. Due to this, these blades are moving. And whenever some fluid is hitting this blade, it is also getting this energy. And it is leaving the system with high energy. So it is basically the power absorbing device. You are forcing this shaft to rotate. Here, the fluid is hitting this shaft. Due to this, it is rotating. So it is basically work done by the system, and it is work done on the system. If we consider a control volume like this, if we consider a control volume, you are supplying power from outside to drive the shaft. Here, if it is a control volume, something is entering and leaving the system. Due to that, it is generating some amount of power. So this is the difference between turbine and the compressor. Have you got the point?
Yes, sir.
Some part of that. If you have still doubt, you just start to read. Even I can clear those doubt in the next class. So finally, hopefully you understood that what these devices do, where you are paying the work, and another thing where you are getting the work. Okay, so now if I consider one compressor, now it will be easier. Suppose if I consider one compressor, some air is entering with low pressure, very low pressure, but finally you need a high pressure. So the outlet air should have a high pressure. Now the question is that who will increase this pressure? Who will increase this pressure? You need some energy. You need to pay for something. That's why the pressure will get increased. So you are connecting an electrical motor. That electrical motor is driving the blades, which is causing the increment of the pressure. Pressure is also a form of energy, just like we know that pressure is also a form of energy. So whatever energy you have supplied through the electrical motor is basically converted into pressure. So this is a power consuming device or power absorbing device. So what is happening? That the system, the Q2, the H2, the leaving stream has a higher energy and the incoming stream has lower energy, and you are adding some work. That's why the incoming stream energy is getting increased. So finally, the work input can be written as m dot H2 minus H1. So how I am getting it? How I am getting it? If I go back to the previous equation, let's see. This is our basic equation, which is applicable for everyone. Here, there is no heat transfer. This goes to 0. Now the question, what is the value of W? Are we supplying W or the system is giving me W?
Supplying W.
Supplying W.
Supplying W.
So
Motor.
this what is the sign of this W?
Negative. Negative.
Negative on the
So
system.
it is
Only the system.
negative of negative W. Is it right?
Yes,
Yes,
sir.
sir.
You understood why it is called negative of negative? Because already
Yes.
negative sign is there and you are considering work addition. So work addition is always negative. Here H2, this is my H2 and this is my H1. So if I ignore the kinetic energy, if I ignore the potential energy, if I ignore the kinetic energy, if I ignore the potential energy, finally I will get minus of minus W equal to H2 minus H1. Please excuse my mouse work. So finally I am getting W equal to m dot into H2 minus H1. What I have written here. Do you got this?
So due to the change, due to the application of work, there should be some change in kinetic energy inside the control volume.
Right, perfect. But what happens, as there will be a kinetic energy, but if we calculate the kinetic energy, the magnitude of this change is, if you take these two difference of these two values, and if you take the difference of these two values, the order of this difference is very small. That's why I'm neglecting it. But actually what you have said is perfectly correct. There must be some velocity change. But this should be, you can write it that in an actual sense, this should be kind of approximately equal to this. Perfect. What you have said
Okay,
exactly correct. Now the last part, if we consider turbine, so what will happen? Some mass is entering into the system, some mass is leaving. During this process, it is creating a work output. Okay, so if I apply it for our steady flow energy equation, what will happen? If I erase it, pointer, erase. So here also my heat transfer is 0 because I am not adding heat. But in real configuration, what will happen? The turbine will lose some amount of heat in the environment due to the heat leakage or maybe the conduction. So this value may be negative in real cases, but the value is very small because I am not supplying heat. Now this W will become positive because it is a work output. So here this is H2 because it is exit, this is H1. So final expression will become m dot H1 minus H2. It should be H1 minus H2 because H1 is having high energy and H2 is having low energy. Then only I am getting a positive W. So this is the application of turbine. So whatever device you consider, you can simply consider the steady flow energy equation, and based on the device, if it is a nozzle, in that case Q and W both are going to become 0. If it is turbine, this W is going to become negative. If it is compressor, if it is a compressor, then this will be negative become positive. So this is the same equation that you can apply for any kind of steady flow devices, so by which you can go for a energy balance and find out that how much work is needed to run the device. Suppose if you consider one pump the pump inlet pressure you know, the pump inlet temperature is known to you. Now you want what is your delivery pressure and delivery temperature. If these two informations are known to you, you can find out that how much electricity I have to give to run the pump. Because energy cannot be created, energy cannot be destroyed. So it can be always conserved.